Okay, so let's solve the following problem. The problem says, if d of x divided into d of x, in other words, if the derivative of x about x equals tan of x, and f of 0 equals 1, then what is the function f of x? Okay, so basically what we need to do here is to take the integral of this function we have here, df over dx, or of the derivative of f. By taking the integral, we are finding a family of functions that can comply with the given condition. This condition will help us find what the real or the actual function is. So let's try by finding. So let's start by finding the integral. Okay. So in this case, we need to find the integral of df, which should be equal to the integral of tan x dx, right? I will use parentheses here. Tan x dx. Okay, so how to find this integral? Well, basically the key here or the trick here is to use the identity to convert tan into a ratio of sin over cos. It is known that, just a second, it is known that tan of x equals sin of x divided into cos of x, right? So we can go ahead and substitute this identity into our integral. So the integral will have the following shape. Just a second. We'll have the following shape, which looks like this. F, since the integral of df is just f, it will be f of x, equals the integral of sin of x divided into cos of x, right? So this will be our integral. This is the integral we need to solve. So now arises the question, how can we solve this integral? Well, in this case, we can use integration by substitution. So the idea of substitution is to substitute, as its name says, an inner function of a composite function for u and also the derivative of u into the integral. So it is easier for us to find its integral. In this case, u is going to be cos of x. Cos of x. Right? So we can now find its derivative. The derivative of cos of x du equals minus sin of x dx. Right? Now, we can try to directly substitute it like this, but there is a trick here. In this case, we can solve the second equation for dx. So we have dx equals minus du divided into sin x. The idea here was to leave the x alone in one side of the equation, so we divided both sides of the equation into sin x. So we ended up with dx equals minus du divided into sin x. So these are the two equations we need to substitute into our problem, right? So these are the ones we're going to substitute. So let's go ahead and do so. Let's copy the integral we need to solve. So let's do the substitution. We know that cos x is going to be u. So we just change this cos x for u. This u we have here. And the x we know it's going to be minus du divided into sin of x. So we can substitute this dx for that. So this is going to be minus du divided into sine of x. Right? So we have the integral that looks like this now. It looks a little simpler, let's say. This can be simplified. We can come and take this negative we have here and write it outside of the integral symbol. So we write it here. I get rid of it here. And these signs we have here, this one cancels with this sign we have here. Since they are multiplying and we have a division here of signs, sine of x divided into sine of x equals 1, so we can cancel them. So let's get rid of this. Let's get rid of all of this and let's just give the du and let's write the sine of x here. Oh, I'm sorry. Let's write a 1 here, right? 1 over u du, because we divided them and it equals 1. Okay. So now it's a much simpler integral. Actually, this is a common case. The integral of 1 over u is nothing more than the natural logarithm of u. So f of x, in this case, equals minus the natural logarithm of u, absolute value bars. Why do we use absolute value bars? Because this derivative is defined for both positive and negative numbers, but natural logarithm isn't. So we use absolute value bars. So it is defined for all the values we have in our derivative. Okay, and really important, plus a constant c, right? Why do we need to add a constant c here? That's because here we are finding a family of functions. A lot of functions, actually an infinite number of functions, can have a derivative 1 over u. That's because no matter what the constant is, it will always turn out to be 0, so its derivative is 1 over u. That's why we need to write the constant here. So the idea is to find out or to figure out what c is equal to. But before doing so, let's substitute u back. So let's copy our function. We have that u equals cosine of x. So we need to substitute that cosine of x instead of u. So we have cosine of x plus the constant c. Okay, so this is our family of functions. The problem gives us additional information that will help us figure what c is equal to. The problem tells us that in this case, let's take a look, f of 0 equals 1. F of 0 equals 1. So let's copy it here. Therefore, we can use this value into our answer here and use these values to figure what c is equal to. So f of x equals, f of 0 equals 1, so we just write a 1 instead of x. This equals minus the natural logarithm of cosine of x, right? In this case, it would be cosine of 0, right? Because x equals 0 according to this number we have inside the parentheses, and all of this plus c. So it's just a matter of solving the equation for c. In this case, let's try to simplify the problem a little. We know that cosine of 0 is equal to 1, right? And we also know that the natural logarithm of 1 is nothing else but a 0. So this becomes a 0. Therefore, our constant c equals 1. So once we know what c is equal to, we can take the original function and substitute the c for a 1. So it will be minus natural logarithm of cosine of x plus 1. Now, this answer has another form, another form in which we can write it. Let me just highlight it. Okay, that will be our answer. Another way in which we can write our answer is if we use the natural or the logarithm properties, the log rules. So we have that f of x equals the natural logarithm of cosine of x raised to the power of minus 1 plus 1. right? Cosine to the power of minus 1 is the same as saying f of x equals the natural logarithm of 1 divided into cosine of x. 1 divided into cosine of x plus 1. And there's an identity that tells us, the reciprocal identities actually tell us that 1 divided into cosine of x is the same as secant of x. So this very same function can be written or rewritten as natural logarithm of secant of x. And this is another way in which we can write our answer. Both answers are correct. They mean the same thing, so don't get confused. Both answers are correct. So that will be the answer to our problem. So I hope this helps. Don't forget to follow me, to click the follow button, and if you like it, a thumbs up, and I'll see you next time. Oh, and by the way, if you ever need some live tutoring, you can click on the link on the descriptions where you can hire me for a live tutoring session via Zoom.